Hey guys, welcome back to the channel. If it's your first time here, we go through math and physics tutorials as well as how to improve student confidence. In this video, we're going over analytic geometry and the equations of circles. I'll be going through how to find the equation of the circle given the center and radius, as well as given two endpoints. This will be part number 1 of a 3-part series related to analytic geometry. By the end of this video, you'll be able to handle any question regarding graphing circles or finding the equation of a circle. If you find this video helpful, please like this video and subscribe to the channel to see more videos just like this. Stick around to the end of this video to learn why you should think of school like a game and why that will result in better grades over the long term. So let's figure out how to get the general equation for a circle, and then we can use that general equation to solve the problems where it asks for the equation of the circle. So if we think about what defines a circle, we usually talk about the radius. So that's this line right here. And really what the radius is the length of the line from the edge of the circle to its center. And it can be in any direction. We could have a line like from there, that's the radius. We also have something over here, that would be the radius. It's any point on the edge of the circle to the center of the circle. And I'm going to call the center of the circle right now, I'm going to call it A, comma B. So it's in the x direction of A and in the b direction of y. That's this point right here in the center of the circle. Now, the length of the line, or the radius, can be expressed as the distance of a line or a segment. So, what I'm going to do is I'm going to draw this line right here in red, and I'm going to say that is our x bar, or the length of this line in the x direction. And then, what I'm going to do is I'm going to draw a line, and we're going to call it y bar. And that's going to be the length of the line in the y direction. And here we have formed a right angle triangle now. We've basically said this r value, or this radius of this line, can be broken up into an x direction and a y direction. So what we can use here is we can use Pythagorean theorem. So with the typical triangle, we'd have something like this, and we'd say this is A, this is B, and this is C, and we would say that A squared plus B squared is equal to C squared. So in this situation, we have x bar squared, and then I'm going to write plus y bar squared, and that is equal to our radius squared, because this is our hypotenuse, or our C in this case. So now we have kind of the equation that defines this r squared line, or this triangle that we have. So what I'm going to do is I'm going to say that how do we figure out what is x bar? What's the distance of x bar? Well, what we can do is we can call this point here x, and this point up here y. So I'm going to say from x bar is really just x, the final point, minus the starting point. So in this case, it's going to be minus a. And then we're going to have, so that's x minus a, or x bar, but we have to do the entire term squared, so it's going to be x minus a squared. And then we're going to be plus, and here we're going to have the y value, or the second value of the line. We're going to say y minus, and then its starting value, which is b. Because this blue line here is really, it could start on this side over here. I just drew it to kind of show you, but this could also be y bar. It's the same distance. So then that b value is the starting value, so it's going to be minus b, and then that squared. And that will equal r squared. And notice that I said a comma b is the center point of this circle. So now we know that for the equation of a circle, x minus a and y minus b, the a and the b term are going to be what dictates the center of the circle. So that's kind of the equation, the general equation of a circle, and we can use this to solve a lot of these questions. So the first question we have is we have a circle that's centered at 4, 5. So I'm going to write 4, 5. That's 4 in the x direction and 5 in the y direction. That's the center of the circle. And then they said the radius was 5. So if we see this situation, what we can do is we can apply this general equation that we've found for the circle. So we're going to write it out, x minus a squared plus y minus b squared is equal to the radius squared. So here, when they give us 4 and 5, in the previous kind of derivation of this general equation, a and b corresponded to the center. So what we can say is that x minus 4 squared plus y minus 5 squared equals the radius squared. So I'm going to write 5 squared. And then now we have this full expression where we have y minus 5 squared, and then 5 squared is 25. So this would be the equation of the circle for this first problem here. Now for our next question, we're actually given the center, which is -2, 3, but we're also given a point, which is 6, 12. So this one we're not actually given the radius. So here, this is going to be the center of -2, 3, and then we're going to have the radius, or sorry, the point of 6, 12. So now what we do for this situation is, since we have the center of the circle, we actually can find out this radius, and we can find it out using our general equation. So again, I'm going to write the general equation, which is x minus a squared plus y minus b squared is equal to r squared. So in this situation, a and b again are representing the center of the circle. So we're going to have x minus, and that's going to be -2, so minus -2, and that's going to be squared, plus y, and that's going to be -3, which was the b value. And that all equals r squared. So here, we can now use this point and sub in the x and y value to find this r value and find the radius. So we're going to say that the x of 6, and then it's going to be minus -2 or plus 2, so plus 2 squared plus y, which is 12, minus 3 squared, it's going to equal the radius squared. So if we do that, we're going to get 8. 8 squared is 64. And then if we add that, 12 minus 9, that squared is 81. And that's going to equal our r squared. So I believe that's 145. So 81 plus 64. Yeah, so r squared is equal to 145. And we can write that as the radius is the square root of 145. So now, this is a crucial part where we have to rewrite the equation now with this r value. So we can write x minus, and it's going to be -2, so it's going to be x plus 2 squared plus y minus 3 squared is equal to, well, it's going to equal r squared, and our radius is root 145, or the square root of 145. If we take the square root of 145 and square it, that's going to end up equaling 145. So we can now use this and say this is our equation of the circle for question 3. So in question 3, we're actually not given the center of the circle, and we're not given the radius. But what we are given are 2 points that are represented as endpoints of the circle. They might be referred to as endpoints, or something that's known as like diametrically opposite points. But what they're saying is really the same thing. They're saying that these 2 points, the line between them passes through the center of the circle. And so what these endpoints are really referring to, or the length between them, is the diameter of the circle. So if we have the diameter, we know that the diameter of a circle is equal to 2 times the radius. And that, if we found the radius, that would give us, point A to, or the distance from A in the radius will give us the center of the circle. So we can kind of work using these points to give us the radius and the center of the circle, and therefore get the equation of the circle, again, which is x minus a squared plus y minus b squared is equal to the radius squared. So if we look at this diameter and this point connecting A and B, if we find the point that's halfway between the A and B points, we're going to get the midpoint of the line, and that's actually the center of the circle. So here, the center of the circle is the midpoint of AB. And what we can do for the midpoint is we can say that the midpoint is equal to XA plus XB divided by 2, comma, YA plus yb divided by 2. So here, the midpoint is going to equal, if we look up at our xa, that's negative 8, and then our b, our point b has an x value of 4, I mean negative 8 plus 4, that divided by 2, comma, and then we're going to have ya, so that's going to be 10, and then it's going to be comma negative 2. So ya is 10 plus negative 2, and that's going to be divided by 2. So here we get our midpoint to be, midpoint is equal to negative 8 plus 4, which is going to be negative 4 divided by 2 is negative 2. And then we're going to get 10 minus 2 is 8, divided by 2 is 4. So that is our midpoint right here, and that is the center of our circle. It is going to be negative 2, comma 4. So now we have the a value and the b value, and we also have this a point here. So we can kind of see that it's a similar question to problem 2, just with the midpoint step in between. So we can say that x minus negative 2, that's going to be plus 2, squared, plus y minus 4 squared is going to equal r squared. And then we're going to sub in, let's sub in our point A. So we could sub in point A or we could sub in point B, but let's just stick with A. Negative 8, comma 10. So that's point A. So I'm going to say negative 8 plus 2 squared plus 10 minus 4 squared is equal to r squared. So we have negative 8 plus 2, so that's negative 6. Negative 6 squared is going to be positive 36, plus 10 minus 4, that's going to be, what is that? That's going to be 6 as well, plus 36, because 6 times 6 is 6 squared, so 36. That's going to be r squared. So r is going to equal, or r squared is equal to 72, and the radius is going to equal root of 72. But now we can give our equation of our circle. So we can have x plus 2 squared plus y minus 4 squared is equal to 72. And that would be the equation of the circle for problem 3. Alright, so I want to talk about how to view school like a game, and honestly why you should. When you're playing a game, whether that be a video game or whether that be a sport, if you lose or you fail at that game or that sport, you typically don't really get down on yourself, not in the way you do academically. You usually don't say, oh, well, I'm terrible at this game, I never want to play it anymore. You would typically, try your best to try the level again, or try the sport again, or work harder at that sport, or work harder at that game to surpass that level or to get to the next step. This is the mindset that you should have for school and for academics in general. If you don't do well on a test, you shouldn't say to yourself, oh, I'm terrible at this course or this subject. You should look at it more like a game and say, okay, well, I made some mistakes last time, I'm going to have to watch out for those mistakes. You're also likely going to have to work harder at that course or that subject, just like you would in a game or a sport. All you should say to yourself is that this game is now proving harder than you once thought it would be. So now you're going to have to work harder to get past that point. If you adopt this type of mindset, I can promise you that your marks are going to increase over the long term. If you view it more like a game and as opposed to something you're terrible at or something that's more negative, you're going to view it as negative and it's not going to have the success you want. But if you view it like something you can get better at, those marks will come and those grades will get better. Thank you for taking the time to watch this video. It's my goal to provide as much value as I can to everyone to help streamline the journey of a student. If you guys like this content, I'd really appreciate you liking this video and subscribing to the YouTube channel to see more videos just like this. I make a ton of content to help in math and physics, as well as improve the confidence and psychology of a student. Thanks so much for watching, and I'll see you guys in the next video.